equals x e to the x over x minus 1. A couple things we can do to start is, one, we can find the zeros of this function. Okay, so when we look at the zeros, we look at the numerator of this function. So only this x can equal 0. X does not equal 0. Okay, so we know that the zeros are going to occur at x equals 0. So we know when we put it in the graph, there's our 0 right there. At x equals 0, we have our 0. We can then look at the vertical asymptote. So the vertical asymptote of this is going to be from the denominator. Okay, so the vertical asymptote is going to occur at x equals 1. So at x equals 1, on my graph here, approximately 1 right around here, I'm going to draw my vertical asymptote. So those are a couple details I can start with. I can also think about the horizontal asymptotes involved here. And the horizontal asymptotes, I can use a limit to infinity. So I'm going to do a limit as x approaches infinity of f of x. Okay, well, if I let this equal infinity, well, the e to the x is going to outgrow the function, the denominator, so we end up with it going off to infinity. So I know the graph is going to shoot off like that to positive infinity somehow. For the horizontal asymptote to negative infinity, we can kind of split it up. So I'm going to split up this limit into two parts. One part is going to be the limit as x goes to negative infinity of x over x minus 1. Okay, so what I'm doing is I'm going to split this limit up into this part here, and also we're going to split it up into this part here. So I'm going to write that as the limit as x approaches negative infinity of the e to the x part of that. So when we evaluate the limit as x goes to negative infinity of x over x minus 1, that's going to be equal to 1. Okay, it's going to be negative infinity divided by negative infinity. And the limit as e to the x goes to negative infinity, that is equal to 0. So the limit then is going to be equal to 0. So what's going to happen is we're going to end up with a horizontal asymptote. Maybe I'll do that in a slightly different color here. We're going to end up with a horizontal asymptote at 0 as we go to the left. Okay, and we don't know if we're going to approach it from the top or the bottom, but it's going off to positive infinity to the right and goes to 0 to the left. Okay, so now at this point we wanted to look at maybe the derivatives to look for min and max points, and then we could do a slope chart. So I'm going to find the derivative of this function. Okay, so x e to the x, when I differentiate this function, I'm going to use a product rule for the numerator. So I'm going to end up with, it's going to be 1 e to the x plus x e to the x. Okay, so that's the product rule for the numerator times the denominator x minus 1 minus, okay, so I'm going to use the rest of the quotient rule here, the numerator not differentiated, so x e to the x times the derivative of the denominator x minus 1 is going to be times 1. And that's going to be all over x minus 1 squared. Okay, so this represents the product. I'm just going to highlight this. This is a product rule of the numerator. And then we have the denominator x minus 1. And then the rest of this represents the quotient rule. Okay, so that blue highlighted part, it just represents how I applied the product rule in the numerator. So then I need to simplify this expression. I want to find where it equals 0. So I'm going to first multiply this all out. So I get x e to the x plus x squared e to the x. I'm going to multiply the x first. Then I'm going to multiply the minus 1. So it becomes negative e to the x minus x e to the x minus x e to the x. Okay, so that's my whole numerator. That's all over the denominator, x minus 1 squared. So we can cancel out some like terms. I've got x e to the x here. I'm going to factor out the e to the x. So I get e to the x, and then I end up with x squared. I'm going to do minus x. I'm going to take that one first, minus x. Minus x, and then minus the e to the x, factoring out the e to the x, I get minus 1. Okay, so that numerator does not factor, and I'm going to make that equal to 0. So I'm going to solve this equation. This portion of the equation here, that does not equal, so I'm only looking at the numerator because I'm making it equal to 0, and that portion of the numerator has no solution. So then I'm looking for the solution of this part of the numerator. So I'm going to solve for that. And I'm going to use a quadratic formula since it does not factor. So I'm going to end up with negative of negative 1 plus minus the square root of negative 1 squared minus 4 times a times c, which is negative 1. And that's all over 2. Okay, simplifying that, I get 1 plus minus square root of 5. Okay, so this is where that value comes in of 1 plus minus root 5 as the x-coordinate of the vertices. So those are going to be my two critical points. So I'm just going to put those into, the values of those are approximately negative 0.618 and positive 1.618. Okay, so then when I do my slope chart here, I'm just going to do this in green. Okay, so negative, this is going to be 1 minus root 5 over 2, approximately there, and I'm going to have 1 plus root 5 over 2 here. Okay, those are my zero slopes. I have an undefined slope at 1. Okay, so testing my slopes, f prime, and we'll choose negative 1. Okay, when I plug negative 1 into that f prime, the denominators, I could just do sign analysis here because the e to the x is always positive. 1 minus x minus 1 squared is always positive. So just plugging into the quadratic, I get negative 1 squared plus 1 minus 1. That's going to be positive, so I know that it's going to be sloping up here, 0 slope. And to the asymptote, I'm pretty sure it's going to be sloping down. We can just plug a number in here. We can plug in 0. F prime of 0 is negative 1, so we know it's sloping down like that. At between 1 and 1.6 approximately, so I'm just going to use maybe 1.5 as a value. When I plug 1.5 into that, I'm going to end up with a negative slope, so I know I'm sloping down still from this side of the asymptote. It goes across like this. And the f prime value at x equals 2, when I plug that into the quadratic part of this again, I get 4 minus 2 minus 1, which is positive 1, or just positive. So there's my slope chart. So I know I have a max at 1 minus root 5 over 2 and a min at 1 plus root 5 over 2 with a vertical asymptote at 1. So plugging in the y-coordinate, I can just plug in to get the y-coordinate here and here. These values are approximately, this one here is 0.2, about 0.2, and this coordinate here is about 13 point, looks like about 13.2. Okay, so when I draw the graph in, Okay, as I sketch in the graph, at this point here, it's going to be very close to the y-axis. We know it's going to come along the horizontal asymptote up to that point, and then start coming down and down the vertical asymptote. Okay, this coordinate, the other min point, we're going to come down, and we know it's coming down like this. It's going to hit the min point here. Okay, that's about 13.2, and then it's going to shoot back up because we already established that the endpoint behavior as it goes to positive infinity is going to positive. So there's my min coordinate at 1 plus root 5 and 13.2. And this coordinate here is at 1 minus root 5 over 2, and it's approximately 0.2, so it's quite close to the x-axis.